Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 30 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2977. Minimum cost to convert string to. So let's read the problem statement. You are given two zero indexed strings, source and target, both of length n and consisting of lowercase English characters. You are also given two zero-indexed string arrays original and changed, and an integer array cost, where cost of I represents the cost of the converting the string original of I to the string changed of I. So let's see this input first. So you have source and target given to you, and both are of same length, and you have two string arrays original and changed given to you. So you can change this string bcd to cde in cost 1. You can change this fgh to thh, this string, in cost 3. You can change this thh to ghh in cost 5. So this is what you can do. So now after this, you start with string source. In one operation, you can pick a substring x from the string and change it to y at a cost of z if there exists any index j such that cost of j is equal to z, original of j is equal to x, and changed of j is equal to y. So it is saying that from the source, let's suppose you pick this bcd. So this is, let's say, your x. You change this bcd to cde. Let's say this is y. You can change it, but only condition is that whatever you are changing, it should be there in the original. So bcd is there in the original, and you are changing it to cde. So this cde, it should be there in changed, let's say this one, and in this cost we can change. So I can change this bcd to cde in cost 1. Clear this part? You are allowed to do any number of operations, but of operations must satisfy either of these two conditions. What are those two conditions? So it is saying that the substrings picked in the operations are, let's say, a to b and c to d, with either b is less than c. So this is should be less than c. So I am saying here a to b, let's say you are picking. So next, if you are picking, so see here, this b is less than cd, or let's say you are picking a b this here and cd, or d is less than a. So these two things given to you. So the substrings picked in the operations are a to b. So a to b, it's nothing but a range, let's say. In other words, the indices picked in both operations are disjoint. So see, a and b here and c and d is here. So one is this, one is this. They are not intersecting anywhere. They are not intersecting. So this is one thing you can do. The substrings picked in the operations are source a, b and source c, d. But this time, if you're picking a to b, so c to d is also going to be same. So here, see, you can do like this. What I'm saying, you can pick like this. You can pick this range. It's the same range again, or you can pick this. This is also possible, but you can't pick like this. So half like this to this, and there is intersecting one. So both the strings that you are picking, the substrings picked in the operations should be disjoint. The indices picked in both operations are disjoint, and the indices picked in both operations are identical. These two things you can do. This is allowed. This is not allowed. So we have to return the minimum cost to convert the string source to string target using any number of operations. If it's impossible to convert source to target, then in that case simply return -1. And note that there may exist indices I, j such that original of j is equal to original of I, and changed of j is equal to changed of I. So here see, original of j, like if you see now this fgh, and it is equal to this thh, but here again this thh again it is given here. So if you see this something like this, fgh you can convert to thh, and it is in thh you can convert it to ghh. So that simply means I can convert this to this directly. So something like this is given to us here. Clear this part? So and here these two simple means bcd, I can change it to cd. Next time I can pick bcde, but I can't pick cde here. I can't start from here. I can start from here, but I can't start from here, or I can pick the same again. These are the options. So let's see how we are going to do this problem now. And these are the constants. So source dot length and target dot length is from 1 to 1000, and both are same. So target consists of only of lowercase English characters, and this cost length, original length, change length, they are all same, 1 to 100. And original I, changed of I consists of only of lowercase English characters. Original of I is not equal to changed of I. This is given, and cost of I value is from 1 to 10 to the power 6. So on side this we have these values. So here see, if you just see this example, A B C D E F G H. Okay, here I copied. All right, so now see this example. So A B C D E F G H, this you need to convert to A C D E E G H H. So here these two are matching, these two are matching. Okay, now see here, B and C, they are not matching, they are not matching. So can I change this B to C? It is not allowed. We can only convert this BCD to this CD. Okay, so can I convert this BC to CD? Is it possible? No, it's not possible. Can I try this BCD to CD if it is possible? So first here I'm checking this BCD if it is there in my original. So here let's say I'm iterating for of n times. Okay, it is available. Then after that I'm going to check if whatever I'm changing, if cd is there or not. So here I have to again check. So here right now it is present here itself, but we have to iterate of n times. If it's very big, we have to find out if this bcde. So then in the change I will just go and I will check if for at this particular index if we have cde. So here I am going to check. Then after that I am going to check the cost. So if that is the case, then maybe I can change this BCD to CDE in cost to 1. But let's suppose here BCD is not there. This part itself is not there. So now what you are checking? You are checking B, C. This is not possible. Then you are checking B, C to CD. Is this possible? Okay. Then after that you are checking bcd to cde, is it is possible. You are trying to search this bc first. Bc is not there. Then you are trying to search bcd. Then maybe you are trying to search bcde. Maybe bcd, maybe we find somewhere here. Then maybe you trying to check bcdef. It's also not there. So you are checking all these substrings one by one. B, then BC, then BCD, then BCDE, then BCDF, then BCDFGH. Like this, you are checking all the substrings. So here, so many substrings you are checking, right? And we don't want to do this. We have to optimize our code here little bit. So what I'm going to do here, since this original and change are of same length, and I'm just converting this BCD to CDE. I'm converting this FGH to THH, and I'm converting this THH to GHH. So, and I know that my original changed, they only consist of lowercase English characters. So I can do one thing here. I can use the trie data structure. Trie data structure. So how it works, trie data structure? So in trie data structure, you have one root. Let's say this is your root node. So in this root node, you have values here from 0 to 25, that like A is for 0, index B is for this, C is for this, then Z is for this. Like this, you have one root node. So let's say this is your root node in trie data structure. Then in trie data structure, after that, what we check? Let's suppose I want to add this BCD. Okay, I have BCD. So let's say I want to add this BCD. So what you are going to do here, first you are going to check if this particular B value, if it is filled or not, right? So right now there is no node for root, there is no children for this root. So we have to, for this B, I'm going to create again one more array of same length, 26 length, and here 0 1 2. But here from this I'm driving now, from this B. So that simply means I have added B now. This is done. Then I'm moving to this node, and here see, this is A, B, C. This C is not filled as of now. There is no child of this node. So from this again, I'm going to drive one more child, 25. So here you have A 0, B 1, C 2, and Z 25. So here you are driving. Now here you have added C. Now after that, you have to add D. So here in this, D is not occupied yet. There is no child for this at this. So I'm going to add one more like this. So here you have 25, 0, 1, 2, A, B, C. So here you are going to add D. So see now, here from the root, I can easily search the word BCD if this word BCD is here or not. See, root, after that I will check if we have child B for this root. So that simply means the starting is going to be this B. Yes. After that I'm just directly going to check C. Then after that I'm directly going to check D. Okay, so it will get more clear when I'm going to draw this complete. Now BCD and let's say CDE. Okay, so from this root C is not filled. So for this C also I have to create one and I have to fill this. So let's say I am adding C. Okay, this is just internal functionality I'm saying, but like this it works. Okay, like this. So C, after that, for this C, D is derived anywhere not. So D, I'm going to check D. Then I'm going to check E. So let's say here this is -1 index. Let's say -1 index. Let's say -1 index. Let's say -1 index. Let's say this is -1 index. So here this one word is completed. Let's say when one complete word is index completed. So let's say I'm giving here 0 and here I'm giving 1. I'm not giving -1. Let's say I'm giving 0 and 1 here. Okay, so now it is very easy for me. So first I am here at B. Let's say A and A both are matching. So let's say I checked this. Now when I reach to this B, so now I'm going to check if there is any substring I have which is starting from B. So I don't need to iterate over all this now to check if any of this starting with B. I can directly go to this trie data structure. I will go to the roots next. I see, oh, it's B, and I want its conversion to this CDE. So here see, at in one go I'm checking that B is also here and C is also here, right? I have to convert this BCD to CDE. So after this root we have B, and after this root we have C also. Then BC, CD, then we have CD and DE. I will not stop until this is -1. Only one complete word is completed, one word is completed and index is not showing -1, let's say. So only then I will change, and then maybe I will add the cost. So here let's say this BCD. Okay, I am adding this key 0, a value 0. Let's say this is my key. And for CDE, let's say I'm adding 1 index or value. Then for FGH, let's say I'm adding 2. Then for THH, I'm adding, let's say, 3. and thh is again I'm adding a unique value, so it's already there now, so let's not add it. Then we have ghh, so for this I'm adding 4. So this is done. So in total we have these 5. So b c d c d e, then maybe you draw for f g h, here f, let's say g, and then you have h, let's say, and then maybe you draw for thh. So here from root it's not starting, so first you have to write t, then h, then h, then after that you have ghh. So is there anything starting with g? No, so start from here, g, then h, then h. So like this you have added. So now instead of checking all the substrings like bc, like b, then bc, then bcd, then bcde, I can directly go here to my root and I check if after root I see anything at this particular level, if I see anything starting from b. So yes, this is starting from b, so there is one possibility as of now. Then after that, let's it's not -1, so let's say I move to c. So b, after b I see c, yes, okay, good. Then after this bcd, you see d, okay, yeah, bcd there, and here we have this 0. That simply means we have found one complete word that is there in my original, let's say. So now from this original I can directly change to this cde, okay, this to cde, and there definitely there will be some cost given to us for that. So that also I need to take care. How I'm going to take care of the costs and all, let's see. So here when I'm going to write the code, then it is going to be very very simple for you, okay, don't worry. So here we have all these values, right? 0 1 2 3 4. So what I will do, I will just create one 2D array, let's say distance of same 5 into 5, 5 into 5, because we have these 5 values, okay. For simplicity I'm writing it like this. I just assign the values to them. So here 0 1 2 3 4, 0 1 2 3 4. So disaster is nothing but from a single source to destination, but here we have different pairs, different starting points, different sources to different targets. So definitely we have to implement the Floyd Warshall algorithm here, right? So how we solve the problem using Floyd Warshall algorithm? So bcd to bcd conversion is going to take just 0 cost. cd to cd, that is 1 to 1, 1 to 1, it is going to take 0. From 2 to 2 it's going to take 0. From 3 to 3 it is going to take 0. From ghh to ghh it is going to take 0. 4 to 4 0. Now here if you see this this thing, so bcd to cde, that simply means I'm saying from 0 to this cde the cost is 1. So 0 to 1 the cost is 1. I'm going to fill it with 1. This is direct, like from this to cde, bcd to cde. Then after that fgh is 2 to thh, which is 3. So 2 to 3 cost is 3. 2 to 3, 2 to 3 cost is 3. I'm filling it here. Now after that we have thh to ghh. thh means 3, ghh is 4. So 3 to 4, uh 3 to 4 it is saying the cost is 5. So let's say I fill 5 here. Done. So this is direct mapping from to with this cost. This is direct mapping that I'm doing. And but about this case where your fgh is this fgh, it is pointing to thh, it is pointing to thh, and your thh is pointing to ghh. What about this case? So here I can say this is your I, this is your j, and this is j, and this is k. So I can say I is pointing to j and j is pointing to k. So for this one node there is one incoming edge, there is one outgoing edge. So for this also we have to find out the cost now. So I to k, right? So here for fgh is nothing but, if you see this, I'm saying it is 2, thh I'm saying 3, thh I'm saying 3, and ghh I'm saying 4. So I can say this is 2 to 3 to 4. So 2 to 4, is there anything as of now? 2 to 4, if you see this array, this 2D array, so everything else now by default it is going to be infinity. We don't know the cost. Here we are just filling the minimum cost in this Floyd Warshall, using Floyd Warshall algorithm. So right now all this stuff is infinity. We don't know the values. Okay, so 2 to 4, this, if you see, uh, this ij and j to k, this is how you are moving, right? So this part, let me mark it here, this part. So 2 to 4 there is no direct path, but 2 to 3 if I go with cost 3, and then 3 to 4 I go with cost 5. So overall 2 to 4 I can say my cost is going to be 8. Can I say that? So that simply means FGH to THH with cost 3, and THH to your GHH with cost 5. So overall I can say from this to this cost is going to be 8. So this is how I'm going to fill all these values. So this is also ready. This is what you do, right, in the Floyd Warshall algorithm. So all other values here, they are infinity, 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 infinity. All this stuff is infinity. So this is how you are going to fill this. This part is also very easy now, right? Clear? So we know that we have to use this Floyd Warshall algorithm to fill the costs. I take care of the costs here in this part, and here I know try data structure because I don't want to try different substrings. So I optimize my code some little bit here using try data structure. And now also what I'm going to do here, this is the conversion I need from source to target. So my, what is my source length? 1 2 3 4 5 6 7 8. So I'm going to create one dp array here, and here 0 1 2 3 4 5 6 and 7, so and 8. So when I say that I want dp of I value, so that simply means it is going to give me something, some value here, which is going to show me that from 0 to I minus 1, when I do the conversion, so what is the minimum cost to do that? Minimum cost to do that. So if I say dp of 1, so dp of 1 is going to be, say, from 0 to 0. So what is the cost? So a to a both are matching now, so cost is 0 here. I'm going to fill by default, not by default but in the starting, if both are matching. So I'm going to fill 0 here. Then after that, here I have to fill value. So dp of 2 means 0 to 1. 0 to 1 means here both these, can I convert them? Both are matching. Minimum cost? No, as of now, no, nothing. So by default all this stuff is infinity. And initially this value what I'm going to fill. So dp of 0, dp of 0 means dp of minus 1. So there is nothing here, there is nothing here, so I can keep this as 0 only, right? And what is this dp of 8? Dp of 8 is going to tell you the conversion, the minimum cost to convert a substring starting from 0 to 7. So that simply means complete. So that simply means here you are going to get the answer. Here you are going to get the answer. So after this here b, so this is not possible, right? Then let's say b c d e. So is this possible? Let's say you are at dp of 4. dp of 4. So dp of 4 is nothing but, dp of 4 is nothing but 0 to 3 you are going to say. So 0 to 3 means 0 1 2 3. That simply means this part, and here this part, 0 to 3. So is this conversion is possible? So yes, this conversion is possible. ABCD to ACDE I can convert, because I know that BCD can be converted to CDE in cost 1. So At DP of 4, I'm going to fill the value, let's say 1. I fill this 1. Now after that, this is E, let's say, and here also you have E. So let's move further. So now this is FGH, and then this is GHH. So here at DP of 8, 0 to 7, what is the cost? So here, yes, you can convert this FGH to GHH. So FGH to GHH, overall cost is going to be 8, right? Because here I proved now FGH to GHH. So FGH is nothing but 2, and GHH is nothing but 4. So 2 to 4, 2 to 4. So 2 to 4 cost is 8. So here at this position DP of 8, I'm going to fill 8. 8. But here 8 is a conversion for this FGH to GHH, right? But here I converted this also na, BCD to CD, so I have to add this cost as well. So overall it is going to be 9. So if you see this example, so 9 is the output. Okay, so to convert this to this, do the following: change substring from 1 to 3 BCD to CD at cost of 1, then change substring 5 to 7 at this one at cost of 3. We can do this operation because indices 5, 7 are disjoint with indices picked in the first operation. So 5 to 7, I am picking here 0, 1, 2, 0, 1, 2, 3, 4, 5 to 7, and I converted this. So FGH to GHH I converted. FGH, no, first what I did, FGH I converted to THH. Then again I pick 5 to 7. I told you that we can pick these or we can pick disjoints ones. So again it picks THH and then again convert it to GHH like this. But using Floyd Warshall algorithm, I did it in one go. Instead of doing it in these two steps, I did it in one go. That is the advantage. That's what I checked in the starting itself. So I to J, no, but what was the case? It is case of like this, indirect mapping, I to J and J to K. So this node has one incoming edge, one outgoing edge. So I can simply say I to K. That's it. So that's what we did. So overall, this is 8 I have written and 1 is from previously. So 1 plus 8 is 9. So all these things I need to take care in my code, and I have to optimize my code side by side. So now what I will do, I will write the code and I'm going to explain all this stuff. How I'm going to, my trie data structure is going to work, how I'm going to take the things. So I will make it very simple, this code. Okay. So now let's understand whatever we did here again with the code. Okay. So I'm going to write the code now. So this is what you have initially, right? I'm going to do all the things step by step so that you can understand the code. So first here I'm going to take int n is equal to source dot length. So this is simple, this part as of now, correct? This is simple, right? Now here let's do one thing. Let's create one infinity variable, and here let's say it is nothing but long dot max underscore value. Done this part, and then step 1 is going to be assign IDs to all the strings. So here I'm just going to add the comment as well side by side. Step 1 is going to be assign IDs to all strings. And what I'm going to do here, I'm going to create one root node. Tree node root is equal to, not tree node. Why I'm writing tree node? It's trie node. This data structure I need to use. Trie node root is equal to new trie node. And here this object of this trie node I am creating here. So let's create one class trie node here. So here I will create the blueprint of this class, how my class is going to look like. So I will say this is my trie. So here I will write class trie node, and in this class try node, what we have, we will have a array, try node array. So here let's name it as children, and you know the length is going to be 26. New try node, and length is going to be 26 of this one. And here int id, I will assign it -1 this time. So this is a unique id if this node ends a string. So it is going to be, let's say, unique id. So I will update this to some other id when my string ends. So we will get a unique id if this node ends a string, but by default we will get a -1 if this node doesn't end any string. So by default we are going to get -1. So this is done. So I have created a object of this try node root class. Okay, this is done, this part. I hope nothing complex as of now. Then after that, what I will do, I have to map all these values like bcd 0 cd. So map, let's use map. So here map, my key is going to be of string type and my values are going to be of integer type. Let's say id map is equal to new hash map. This is done. Clear? Then here let's create one variable next id. So in next id it is 0, but I will fill values like this 0 1 2 3 4. Okay, now how I'm going to do that, that is also going to be very simple. I know that both original and changed are of same length. So here I'm just going to run one loop. Int I is equal to 0, I is less than original dot length, and here I plus plus. Here I will say that if my map doesn't contain this key, so we are not adding the, in map we can only store one key, right? So I'm not adding here thh here, and here I'm not writing it two times. I'm just adding one unique value 3 here. So here I have to write if my id map doesn't contains key, let's say original of I. So in that case what I need to do, so in that case I will add this particular key in my map. So id map dot put key is going to be this original of I, and the value is going to be next id. Clear this part? So I have filled this next id in my id map. Now here what I will do, once this is done, after that I'm just going to insert. Okay, I'm going to call one method insert, and in this insert method, okay, this insert method I'm going to use for the insertion of nodes in my try node. Okay, so in this insert what I will do, I will pass my root. I have to start from root always. Then I will pass this word. Okay, this original word I have, let's insert this word also side by side. And here this time in the next id, okay, so next id for this one I will pass 0. So here if you see, for bcd I'm taking 0 here, and when I draw this, so bcd, so here I was also taking 0. Then after that cd, so here it was I'm taking 1, and here also I'm taking 1, right? So what I'm going to do here, I'm going to pass the next id which is 0 as of now, but for my future iterations whatever I will do after that, okay, as of now in this method I'm passing 0 only, but for the future I'm just going to increment this next id whatever I will do in the future, but for this current method I'm passing 0 only. So here that's what I'm doing here. So this is what I'm doing here for this one. Same way I'm checking this BCD, then after that I'm not checking FGH. After BCD, I'm checking this CDE, because BCD and CD both are at same index. FGH and THH both are at same index. So I'm just going to make code a little bit smaller here. So in this, I will also check changed part. So here, just make it to changed. That's it. So this is done. See, this is done here. So step 1 is completed. Assign IDs to all the strings. Now step 2. Step 2 you have to do here. That is nothing but build conversion graph. Build conversion graph. But before building this conversion graph, first let me write the code for this insert, how this insert is going to work. Okay. So here, this is your main method. Okay, this is your main method. Now here I will write the insert. So here you write private void. I'm inserting the trie node, right? Here insert, and in this we are always going to start from the root. So here I will say tree node root, and here the word which we have to add, string word. Let's keep it small. And here ID. So ID, whatever ID we are passing. So what I will do here, first thing, I'm going to start from my root. So I will say try node is equal to root as of now. This is my current node root, and then we have to, in try, I'm adding words step by step. First B, then C, then D. It's not directly B, C, D. So I have to iterate over characters. So char ch in word, the current word, just change it to char array, to char array. So you have changed it to char array. Okay. Now in this, what you need to do first, for this particular word B, so B is at which index? So that you can do using this int idx is nothing but the character that you have from this subtract a. So character, so you are going to get the index. So I'm going to check if at this particular index do we have already a trie node formed. So if not, then we have to form this at this particular index. So here I'm checking if current node, which is root. So if node dot children, its children add this idx. So right now it is null na. So here if it is equal to null, so in that case only what I will do, I will update my node children dot idx, right? So see here, from this B only I'm driving. So I go here, this is empty. So from here only I'm driving, but a new trie node is equal to new trie node. So I'm driving this new trie node. I'm creating one object, and this trie node consists of, again, this complete array of 26 length and ID equal to -1 as of now. This is done. And next time for B I'm done, but I have to iterate over all the other characters as well, right? So now next time I'm going to check this, as this is going to become my current node, and for this node I have to fill this like this. I have to move. So my node is going to be, I can say node dot children in the idx, right? So this is done. And once this complete loop is over, then that simply means I checked the complete word. So here in the node dot id, okay, in the node I'm just going to assign the id equal to id, the id that I'm passing from here. Okay, so in the end to that particular node, wherever I am, if I have checked complete tree, so I'm just going to add the id if I checked complete word. So that's it. This is your method that you need to write for insert. That's it. And then again we go to main, and now we have to start from here. So I hope that there's no difficulty yet in the code. Clear this part as of now? Okay, now step 2 is the build conversion graph. So here we have to create 2D graph. I told you here, this 2D graph, and here it is 5 into 5. 5 is nothing but length of this one. So I can say this is nothing but 0 1 2 3 4. Okay, so these are the next IDs I have created. So and every time I'm doing next ID plus plus, so 4, after that it becomes 5, but for 5 we are not able to find anything, but 5 is the current. So 5 into 5 length I can form, right? 0, then 1 we form, then we do plus plus, then we form this 2, then we do plus plus, then we form 3, then we do plus plus, then we form 4, then we do plus plus 5. But 5 we are not able to form anything, so 5 into 5 I am saying form the length. So 5 is nothing but next id, you can say. So here I can say int distance is equal to new int, let's take a long distance is equal to new long, and here just pass next id. Simple this part. Okay, now I told you initially fill all the rows with infinity. So for long row in distance, okay, here just fill, you can do arrays dot fill, and here row, and here comma infinity. So this is what you need to do. And here if you see, this is 0, this is 0, we have filled, right? 0 to 0, 1 to 1, 2 to 2, 3 to 3, 3 to 4 to 4, all this should be 0 now. So here I will update this part as well. For int I is equal to 0, I is less than next id, and here I plus plus, and here distance I to I. So I told you that it's 0. So nothing difficult in the code as for now, right? And after that also there is nothing difficult. Again, what you need to do, just iterate over this array here. So I'm just going to copy this for simplicity. Let me remove it. Okay, for int I is equal to 0, I is less than original dot length I plus plus. Now I have to fill this from and to. I have to update these values in my distance. So from where I'm moving, so I can say int from is equal to nothing but the id map dot get key. Key is nothing but keys this original of I, that particular word. From this particular word, right, where I'm moving, from this particular word, I am moving, let's say to id map dot get, and here changed of I, this is where I am moving, changed of I. And what is the cost to do that? So I can say distance of from and to. So see, very simple, right? So it is going to be, I told you, math.min of, if I have already updated this value in the past, maybe, so keep whatever the minimum, you have to keep this, or cost of I. This is how you have to update. Okay, this is how you have to update. So now this is done. Now after that, this is direct mapping. If you see, this is direct mapping, direct mapping from to. But maybe I to j and j to k, that scenario I have also told you right here. If you see I to j and j to k, so this we are going to take the help of Floyd, Warshall, and this is also going to be very simple. So for int k is equal to 0, k is less than next id, and k plus plus. And for int I is equal to 0, I is less than next id, and here I plus plus. And here if see, if I to k, if I to k, distance is infinity, okay, distance is infinity, simply you can do continue. If I'm saying if distance of I to k, so here I'm actually taking like this, I to k, and I'm taking like this, okay, not like this ijk, let's say I'm taking k here. So I to k, if distance is infinity, right, so that simply means I'm not reaching to this. So why I need to check further? Okay, so in this case I'm saying just simply continue. If distance of I to k uh, is equal to infinity, just simply continue. All right, but if not, then we have to proceed further. Int j is equal to 0, j is less than next id j plus plus, and here what we need to do, if k to j, if k to j is also infinity, then continue. That simply means k to j there is not part. So here I will say if distance of k to j is equal to infinity, then again continue. Otherwise you have to update distance from I to j. Okay, so only if path is there from I to j, that is going to be the minimum of. So here I will say math dot min of, I will pass this distance of I comma j. All right, and here I will say distance of I to k plus distance of k to j. So very simple, right? This part, this is done. So this Floyd Warshall is also done. So I hope there is no difficulty as of now in understanding the flow of this code. Whatever we write, you understood everything, right? Now final step, final step here, final step is going to be step 3. Let's say dp over source, dp over source. So here I told you have to create one dp long. Dp is equal to new long n plus 1 and fill all the values in the dp to infinity. So arrays dot fill, and here you have to write dp, and here you have to write infinity, and dp of 0 I told you in the starting that simply means 0 to minus 1. So that is there is nothing now, so 0, just write it 0, this cost. Then after that you have to update the characters in the source to your target. So here s is equal to char array, I'm creating source to char array. Same way create one for, this is let's say your source, create one for your target. So this, let's say t, and here you have to write target to char array. Now you have to start for int start is equal to 0, start is less than n, and here start plus plus. So I'm running one loop, and here if dp of start itself, if it is equal to infinity, that simply means I haven't reached to this as of now. Until this start, the cost is infinity. So simply continue from here, continue from here. Okay, continue from here. So here you know that dp of 0 initially I have updated to 0. So if right now dp of 0 is not equal to infinity, right? So then you have to update your case 1 here. So let's say case 1 is nothing but single character match, single character match. This is your case 1 when your single character is matching. So that's simply how you can check. So I told you you have to just move further. So if s dot start, s of start, if is equal to t of target, t of start. So if both are matching, t of start. So if both the characters are matching, then in that case dp at start plus 1. So that simply means dp from 0 to start. Okay, so 0 to 0 until dp of 0. So this value you are going to update with math dot min of the value which you have here, dp of start plus 1, and the value of dp of start. So this is how you are going to update it. Okay, so I told you here, this is how we fill this part. So this a and this a both are matching. So if both are matching, so cost will be 0 only, right? So 0 simply means until here. Okay, so here, if you know, if you have something like this a b c d and g h j and d, so if you know this a b c to g h g what is the cost, then here it will not create any impact for this overall, right? So this is what I'm going to do. So if I am here, so until here, if I know the cost, that's why I'm writing here dp of start. Okay, and overall what is the cost as of now, that I will take. Maybe previously we have calculated that value, so whatever the minimum among them, we have to just update it at this dp of start plus 1. So this is nothing but case 1, single character match. Now case 2, case 2 is going to be, case 2 is going to be substring conversion, right? So here, now see, in shortcut I will do this try node, source node, try node, source node, it is starting from root, and my target node also is going to be start from root only. So here I will say tgt. So let's say I am comparing, let's say this BCD to CDE. So see, B is also starting from here, C is also starting from here. Both are starting from here only, from the root. So now see, this is going to be how it is going to optimize my code. So end. So substring I'm picking, not a single character. So definitely this substring is going to end somewhere. So end is also, I'm going to maybe start it from start only. Then here end is less than n, and here end plus plus. And here source node, I will say, is going to be the source node, and here I will check the children of this, children, source node dot children, and here I will pass s dot end, s of end, I'm going to pass this, and I'm just going to pass minus a. So I will check if we have any children here or not. Same way for the target node also, here I will write tgt target node is equal to target node, target node dot children, and I will check if we have t of end. Okay, t of end minus a in that, right? So this is what I'm checking. So if anywhere we don't have any children, right? So here if you see b, I want to convert it to c. So if b I have, c I have, then only I can check for b, c to cd. Okay, but if not, then I have to stop now. So here I will write if my source node, if it is equal to null, or my target node if it is equal to null. So in this case I will simply break, no need to check further, break it. But we have to carry or proceed further if my source node dot id. Okay, so complete word only I can change now. So if id is not equal to -1 as of now, and my target node id is also not equal to -1. Okay, so if this is the case, it should be target now, target node dot id. So if both are not equal to -1, so in that case, if both are not equal to -1, that simply means we reach to the end. Then we have to check the cost from this to this. So here long c cost is going to be nothing but dist, distance of, I can say, source node dot id, source node dot id, and here I will say tgt node dot id. So here in the end, if you see 0, we are storing this id, and here 1. So 0 to 1, if you just go here in this, so 0 to 1 cost is 1. So that's how you have to update. Okay, so this is done. Okay, and if this c value, c is not equal to infinity, right, only then you have to actually update. C is not equal to infinity, and here in that case you have to update dp of end plus 1 and plus 1. Okay, that's it from start to end. Okay, dp of end plus 1 is equal to math dot min at. So here, just like always, we have to update it. Maybe we have previously calculated somewhere, so we may get minimum somewhere else. Or dp of start, so start has value from 0 to start minus 1. Okay, in this plus c, so previous costs I have to maintain. Okay, new cost and the previous cost, so whatever I will get, I will update it here, and that's it. And in the end you have to return what? You have to return dp of n value. So that is nothing but dp of n. So if this value is equal to infinity, then in that case simply return minus 1. Otherwise you have to return what? You have to return dp of n. That's it. That's it. So this is your code, just 97 lines of code. Okay, so now let's run it and see if the code issue will try to fix that. So yes, there are some issues, so we have to fix them. Here you are passing tree node. Okay, let's run it again. Oh nice, good. So now let's submit it. So see, our solution is set, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.